This is the replica of the IBM Experimental Schools computer that I made a while back, and when I did that originally I rewrote everything in C running on the Pico based on documents that I found on the internet and also on a trip to Oxford University. And there's two main parts to the instructions that this runs. There's sort of standard single address instructions, they're called, and there's also extra codes, which are programmable instructions, so you can actually code the extra codes in the single address instructions and implement various instructions. And the original machine actually used those extra codes to implement floating point instructions. And those extra codes, because they were in core store, they just stayed in there in the non-volatile core, and occasionally people might have to re-enter them, but that listing and those instructions were lost. I couldn't find those anywhere. But one of the people that used this machine back in around about 1970, who's actually in one of the photos, Tony, he had in his loft for 55 years or so a listing of those extra codes. So I've taken those and I've actually built the framework within this replica to run extra codes and implement some of those instructions as proper extra codes. So they are implemented in the single address instructions of the machine, but they do appear as instructions in their own right. We'll see one in a minute. So this, I say it's running the original extra codes, it's not actually running the original extra codes here. It's running a program that Tony wrote 55 years ago or so to play noughts and crosses. And that was such a complicated algorithm that he had to use the space that was normally used for the extra codes to implement some of his program. I think some of the original extra codes are still there, and we'll see that in a minute, for entry and display of the playing board. So we've currently got 17 up there. That's the IAR, the instruction address register, and if I run it you can see that we've got a playing board here. So it's 9 dashes, and above it is an extra code instruction. 7.8 is an extra code instruction which says display the contents of, in this case, store locations 10, 11 and 12, and that's what it's displayed there, which are the 3 lines with dashes on. It's 10, 11 and 12. You can see the addresses on the other side, and that is an original extra code. Now interestingly, as well as a noughts and crosses program, we've got a 55-year-old hack, because it shouldn't be possible to display 3 dashes. That's a minus sign for negative floating point numbers, and Tony's original program does use that as the playing board, but he can't remember, and I don't know, I can't see a way that you could actually do that. So somehow he managed to actually create a value in the core store which was 3 dashes, which he then uses in the program to create the playing board. But anyway, the playing board codes the positions as 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I play position 1 and then press run, the machine has played the centre square. So I'm 1 and the program is 0. So let's go for 7. Go for a simple attempt to win. And it's played, so it's blocked me and it's now attempting to win. So let's go for 6. Am I going to win? Am I going to lose? Right, so I think this is going to end up as a draw, isn't it? Because I'm going to have to play 8 and don't think it can win, and I can't win either, so I'll play 3. So there you go. I mean, it's playing sensibly, and a draw. So you can then press run a couple of times and it resets back to the playing board. So there you go. That was a game of noughts and crosses, or ones and zeros, from 55 years ago.